So we're going to learn to calculate half-lives. And what does that actually mean when they talk about a half-life? Amount of time it takes for half of it to decay. Yes. And this would be the process that they use in dating things. And by dating, I mean, like, when was it first there? They can go back and say, when was this actually present in time? Okay? They use different isotopes to date things of different ages. It just depends on how far back they're trying to go. Okay? I gave you the 4-page handout you were supposed to read, and in there you have this little table, and these are some common half-lives. Okay? Uranium's half-life is 4.5 billion years. Carbon-14 is 5,730 years. So if they're going further back than that, they wouldn't use carbon-14. Does that make sense? Because it's only 5,730 years for about half of it to decay. No, carbon's not a short time. I mean, it is short, though, compared to like 4.5 billion years. Yeah. Okay, so let's take a look at half-life. When I have a sample of something that has not decayed, it has not decayed. That's like the beginning, okay? And we would say that that's equal to 100%. Okay, so this has not decayed. He would be the start of our sample. Does that make sense? Kind of. According to the definition, a half-life is how long it takes something to decay to half of its original. So what would be half of the original? What's half of this? 50. Yeah. Okay. So our next part would be all of this is decayed and I'm left with 50%. This is half of my original sample, so right here, this is the first half-life. Or one half-life has passed. Now, I just showed you from that other paper, everybody's half-life time depends on which element is in there. Okay? So, I'm doing this in general, like just what actually takes place. So what would happen after this? Half of this would decay and I would have 25% remaining. So if we take our circle and we say that much, all of this has now decayed. And what do I have remaining? 25%. Which half-life is this? The second. So we can't count the first one as a half-life because he hasn't decayed yet. Does that make sense? Decaying means like maybe he spits out a helium nucleus. Your alpha decay, your beta decay, what we did the other day, that's what they can go through, those processes. Maybe he turns his proton into a neutron. All of those things are types of decay. Is this kind of making sense? This is just dealing with the time it takes to do those things we talked about last week. In the next step, half of that is going to be gone. So what's half of that? 12.5. So maybe our circle would look like all of this is decayed. Which half-life is that? The third. Okay. What's my next half-life? .25% remaining. It's the fourth half-life. We would have about so you start with this, divide by 2, 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 and you just keep on dividing by 2. Okay? Now, unfortunately, I don't like this either, but there's another way that they can express half-lives, and it's with a fraction. Yes. Okay? Okay, well, you break this down. What would this fraction be? 1/2. What would that fraction be? 1/4. What would this one be? 1/8. One 1/16. What would the next one be? 1/32. I'm not going to draw it because it would be so small. What would my percentage be? 3 point what? 3.125%, and that's the fifth half-life. Okay? So, to be able to work my problems, you really, really, really have to kind of memorize this stuff right here. Yeah, everything is because it's half. So, this is going to be your puzzle piece that you need to be able to understand the other parts. Okay? Everybody with me? All right, let's actually try a problem. I didn't even give you a problem yet. This is just kind of like a visual to break down what's going on. We are going to talk about iodine 131. Iodine 131. The half-life is 8 days. Half-life is 8 days. How much of a 40-gram sample will be left after 8, 16, and 32 days? Okay, so I'm starting out with my whole sample. Starting out with my whole sample, right? How much does it tell me is my whole sample? No. $40 grams. This is 40 grams, a 40-gram sample. What did they say the half-life is? 8 days. So this one happens at which point? How long did that take? 8 days. How much is going to be decayed? 50% is decayed, half is gone, and how many grams is left? 20 grams. Who's confused? There's the first answer. Nobody has a question for me. Okay? The next part, they want to know 16 days. So which half-life is that? It's the second half-life, the next one. Y'all don't get it? It's every 8 days. So plus 8 more days. So the next half-life is at 16 days. How much is going to be decayed? Well, or how much is left? 25%. All of this is decayed. So how many grams would that be? 10 grams. Who doesn't understand? Y'all, you can take your calculator, start at what they give you, and just keep going. Divide by 2. 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 Like it just keeps decaying. It just keeps going and going and going. Okay? So at 16 days, we would have 10 grams left. We need to know 32 days. What do I do? You want to divide this by 2? How many days is this? 24 days. And this is 5 grams. Is that what they asked me for? Nope. So how many, what do we need to do? How many days? 24 plus 8. How many days is this one at? 32. This is 32 days. And we should be at 5 divided by 2. 2.5 grams. So 8 days was 20, 16 days was 10, and 32 days was 2.5. Good with that? Okay. If you start with a 100 gram sample of this, what's this? Read this to me. Carbon 14. How many grams will you have in 2 half-lives? It's basically the same thing that I did above, but there's a shorter way to do it if you don't want to draw the pictures every time. I'm not going to lie to you, I draw the pictures a lot. I just like to. I'm visual. I like to see it. But there is a shorter way to do it if you don't want to draw the pictures. Okay? So, well, yeah, you've got to know what this is. You've got to know what 2 half-lives is. Okay? So what's my sample? It's carbon 14. How many grams do I have? Okay, I have 100 grams and 2 half-lives. What's that equal to? 25%. So if I multiply that by 0.25, I'm going to get my answer. How did they know to multiply by 25%? What is the second half-life equal to? Yes, you could also multiply it by a fourth. So you could do this, or you could do 100 grams times 1/4 equals. What's the answer? Huh? No. 25 grams. Put that in your calculator. 100 times 0.25. That's why I told y'all to get calculators. You're going to have to be able to do all this by yourself. How many years would that take? How many years would that take? Anybody have an answer? What do we have to know? You don't have a clue at all. Okay, so what do we know? What do we know right now from the first problem? There's 25 grams left after 2 half-lives. So we know that we've had 2 half-lives, right? Okay, I want to know how many years would 2 half-lives be, basically. No, no. It's 11,460. How'd she get that? That's right. She got the right answer. Selena. It's on your paper. This is a great little sheet. What is carbon 14's half-life? It's in your binder. It's the one that y'all had to read.
Oh, the radio.
Yeah, it had, yes. Yes. Look, iodines is on there too. These are common ones. So, okay. Yes, so 1 half-life is 5,730 years. How many did we go through? 2 of them. Does that make sense? Huh? Yeah, I don't know why you got confused. Your answer, you were correct though. So, watch. This is the same exact thing, but it's worded differently. This is the same thing that we just did, but it's worded differently. How old would a fossil be if only 1/8 of its original carbon-14 is remaining. How old would a fossil be if only 1/8 of its original carbon-14 is remaining? It's the same thing. But it's written a little differently. You got the answer? Anybody got the answer? What you got? Nope. We're still dealing with carbon-14. We're still talking about carbon-14. And I said it's just like what we did, but I changed it to read 1/8. No. That doesn't even matter at this point. That doesn't even matter. I'm looking for how old, like age.
45,000.
No. Okay. What? Yes. Okay. What is this? What's this equal to? What's this equal to? 3 half-lives. 1/8. Where was that at? Remember on the original. 1/8. Third half-life. Y'all, I'm still dealing with carbon-14. If something went through carbon-14, if it was carbon-14 and it went through decaying, how much would 1 half-life be? Oh my goodness. Y'all just aren't wanting to think today. What is 1 half-life of carbon-14? 5,730 years. How many half-lives is 1/8? 3. I told y'all it's the same exact thing. I just wrote it differently. Yes, I know. That's why I looked at you and told you that. So I showed you 2 different ways that they could write the same question. That's really not even a hard question. Either I'm going to give you the half-life or I'm going to let you look it up. I'm not going to make you memorize all their half-lives. So that part shouldn't matter. That it's not as bad as it seems. Are y'all okay with this? A little bit better? Okay. One more. What is the half-life of a 100-gram sample of nitrogen-16 that decays to 12.5 grams in 21.6 seconds? Did they give us the half-life? No. The question says, what is the half-life? They didn't give it to us. This question is designed for you to calculate it. What did they tell us? We start with 100 grams. And it decays to 12.5. Okay, so 100. What would this one be? What would this one be? 50. What would this one be? What would this one be? And they're telling me how long did it take to get to this? 21.6 seconds. And Autumn just said 12.5 would be at the third half-life, and she is correct. So if it took them 21.6 seconds to get to the third, they're saying how much is 1? So you take 21.6 seconds and divide it by 3. Does that make sense? It's actually 3 half-lives, and it's going to be 7.2 seconds per half-life for every half-life. Okay?